Sharing. Do you see the slide?
Yes.
Yes. So today we are going to continue our discussion about the soil formation. So last time we used to have a definition for the soil. We say that when we say soil, we are going to describe layers of materials. Okay, but we have like 4 conditions to describe that layers of materials. Do you remember the first condition for that? Anyone can recall the 4 condition or one of the conditions to describe the layers of material?
It's caused by weathering.
It caused by weathering. Yes, you're right. Very good. It's created by weathering of rocks. What else?
It's susceptible to addition and loss also.
Yes, it's going to experience addition of new materials and losses.
Loss of organic material.
Original
material. Sorry.
And the last thing, it's going to go through modifications. Okay, so if you have these 4 conditions, then we have a soil. And also we say that soil is very important for humanity. Why?
It's vital for agriculture.
Because of the plant and other things come to with soil.
Home gardening.
Yes.
Vital for the agriculture, for home gardening, and for
forestry and ranching.
Again?
Foresting or forestry and ranching, which is
forestry and ranching, which means that
growing of animals.
Yes, you are very right. Yes, very good. And also we talk about the constituents of the soil, right? We say that the soil, it consists of minerals and consists of water and consists of air, and also it consists of organic matter, right? And we say that since the parent rock is going to be different, it means that we have a different type of soil. Okay, and also we'll talk about how the soil is going to develop. So we talk about the soil developed through, we have inputs of new materials, we have losses of original materials, and we have modification through physical mixing and chemical reactions. And also we say that soil modification is going to be divided into transformation and translocation. And also we'll talk about, we said that we are going to treat the soil as a geosystem, a system of inputs, processes, and outputs. Do you remember the inputs for the geosystem of the soil? So the inputs
Doctor, planets and
the decaying of plants and animals,
rocks and dust.
We call, yes, we have the dust, and we have the organisms, which include the planets, plants and animals, and also we have the most important one, which is the
humus.
The humus come from what?
Animals and plants.
But so it's in the category of the organisms. The organisms later on it will convert to humus. But now we need to talk about the fundamental inputs to the soil. You already mentioned organisms. You mentioned the
water.
Dust, and the most important one is
water.
Not the water. The most important one is the weather rock. You need to have weather rock along with organisms and dust. And regarding the processes, we divide them into transformation and translocation, right? So the transformation, we know that when a soil ages or matures, it will undergoes or go through a set of transformations. For example, we said that the humus, it will provide nutrients for the plants, okay? And also we said that through the chemical weathering, we will have transformation. For instance, the feldspar, will transform to be clay minerals. And regarding the translocation, we say that translocation mean the vertical movement of materials within the developed soil. And we said that the water is the main agent of translocation, because the water, it has the ability to move from one point to another. And also we have a process called leaching. Do you remember the process leaching? What does it mean? The leaching process. Anyone recall what does it mean? So we say that the leaching process. Yes, speak.
When water moves some minerals down to the soil.
Yes, the water will try to selectively choose a certain minerals to move it from one layer to another. We call this process leaching. So we talk about also we talk about this picture here. We say that this picture summarize all the processes, the inputs, and the processes. And I think last time we stopped here, right? We talk about what makes the soil diverse. We know that the soil from one place to another is going to be different, right? If you have a soil in deserts, the layers of the soil is going to be different than temperate soil or tropical soil. Okay, so we have the climate. How do you think the climate is going to change the soil? How do you think the climate is going to change the soil? In which manner?
The amount of water in it?
The amount of water, which means that the total amount of rainfall. So if I have a large amount of rainfall, of course, the layers of the soil is going to be different than a place where it has a low amount of water. What else? Also the temperature. If you have a high temperature, the soil is going to be different from low temperature, right? So
Sunlight.
Also, yeah, the parental materials. You know the parental materials. We know that in order to have a soil, we need to have weather rocks, and to have weather rocks, you need to have a source for that. We call this source parent rock or parental materials, and also the topography. Anyone can know what does it mean by topography? When we say topography, what does it mean? In surveying, those who are taking surveying course, we didn't talk about topography.
دكتور مو يعني طبقة الأرض السميكة تكون؟
No,
أو شيء زي كذا.
topography, it means that I have different elevations for the land. For example, the elevation of that point is going to be different from that point. So, and the elevation is very important because if you have a steep slope, then the thickness of the soil is going to be very small, because the wind will go. The wind will try to get rid of the weather rocks. Where if you have a flat land, the thickness of the soil is going to be very high. And also the organisms is very important, because in some places you might have a large number of animals, and also you may find diversity between the animals itself. So this one is the also a factors affect the type of the soil. And the last one, of course, is the time, because the more time you have, that means the soil is going to be developed more. So if you have a lot of time, that means the thickness itself is going to be thicker compared with a soil with lesser time. Okay, so let's start to talk about each and every one of them. Let's talk about the parental material. We know that the source of weather materials, matter from which soil develop, is called the parent material. Okay, we know that when we were talking about the inputs of the soil, we say that we need to have weather rock. So from where we can get the weather rock, we'll get the weather rock from the parent material. It could be granite. It could be, for example, limestone. So if your parent material is granite, or your parent material is limestone, do you think the type of the soil is going to be the same?
No, doctor, definitely not.
Of course not. So the parent materials play important role in the diversity of the soil. Gradually, the parent material, it undergoes physical and chemical changes at the process of the soil formation progress. Of course, even though we will have physical and chemical changes, but if the parent rock is different, that means the component, even though you will have formation, the final component of the soil is going to be different. Also, the climate. The climate seems to be the single most important factor. It's a very important factor in determining the nature of the soil that develop. When we say climate, climates mean that the total rainfall and also the distribution of rainfall during the year. Because I know for some countries, maybe they have like 6 months of raining, right? While other countries.
What the meaning? What the meaning by this description?
Distribution, that mean
Yes.
For example, here in Medina, here for example, the rainfall season is going to be how long here?
Just 1 month or
Just
less.
1 month. Just
Yes.
1 month. While
Yes.
some countries you will have the like 6 months of continuous rain falling.
Yes, like Malaysia and this countries.
Yes. So that it will be reflected into the soil diversity, the type of the soil. That's what it means by distribution of rainfall during the year. Please close off your phone. Okay. And also the range and the average temperature during the year. For example, here we have a high range or a higher range of temperatures. Compare with countries where they cannot even see the sun. Okay. So also this one is a very important factors. The rainfall, the distribution of the rainfall, and the range and the average of temperatures. So why is this important? Because this one is going to determine the rate and the amount of the chemical weathering and also the leaching process that will take place at a given location. For example, if you are living in tropical region, do you think the leaching process is going to be in high amount or low amount?
Should
High
be
amount.
Excuse me, sir.
Is going to be in high amount because the leaching process
Doctor,
depends on the
excuse me,
amount of water.
Doctor, sorry for interrupting you. Jihad al-Muhammadi has not. He can't access for this lecture. Can you please add him?
Okay, I will try to do that.
Thank you so much.
Okay, so we were talking about the climate, okay, and we said that the climate it means that the total rainfall and the distribution of the rainfall during the year, and also the range and average temperature. All of these factors is going to help us to determine the rate and the amount of chemical weathering and leaching. Do you see the picture here on the right hand side? We have like 4 types of climate. We have polar, we have temperate, we have desert, and we have tropical. Okay, so if we have a polar, you see the result on the unweathered rocks. It seems like we don't have chemical weathering and leaching because of the polar climate. Where if we have a temperate climate, that means a part of the rock is going to go through chemical weathering and leaching. If you have a desert, also it means that the chemical weathering and the leaching is going to be very small. While if you are living in tropical region, it means that the chemical weathering and the leaching is going to take place for a great deal of amount or a large amount here. So the climate has a large effect on the unweathered rock, or it has a large effect on chemical weathering and leaching. The third factor is topography. So a thick soil can accumulate under land that lies flat. So here we have the parent rock here underneath, and here we have a soil. Like you can see, here we have a slope, and here the land is almost flat. If the land is almost flat, that means the soil is going to be thicker. And if I have a steep slope, that means the soil is going to be thinner, mainly because the weather rocks may washed away by wind or something like that. So a thick soil can accumulate under land that lies flat, like this one. But on a steep slope like this one, a weather rock may wash away before it can evolve into soil. So if all factors being equal, soil thickness increases as the slope angle decreases. The slope angle decreases, that means the thickness is going to increase, if we assume that all the factors are being equal. Okay, any question about topography? Yeah, is it clear for you?
How the rocks under the soil are getting weathering?
Through physical and chemical weathering. Physical and chemical weathering that we have discussed in the previous lecture, that will cause the weathering of the parent rock.
Only for the rocks outside the soil, right?
Yes. So this one mainly is going to be chemical. Chemical weathering. Yes.
Okay, thank you.
Also, sometimes the underground water. Remember the underground water? The underground water may cause the physical weathering. Okay, but mainly it's going to be chemical. Okay.
Yes.
Any other question regarding topography? So also the organisms, which means that the plants and the animals, when we say organisms, it means that it refers to diversity and the abundance of organisms living in the soil, which means that how many types do you have of animals? The numbers of the animals. This one is the major factor controlling the soil formation. So different kinds of plants extract or add different nutrients and quantities of organic matter to a soil. And also some plants have deeper root system than others and help prevent soil from washing away. So we have types of trees which has the deeper roots, and if the trees have a deeper roots, that means it's going to prevent the soil from erosion. Okay, so organism also is the major factors to control the soil formation. And the last factor here is the time. When we say time, it refers to amount of time that the soil has to form. And younger soil tend to be thinner and lesser developed than an old soil. So if you can see in this picture here, this one is the younger, thinner soil, and this one is the older, thicker soil. Since the soil here is older, that means the soil is going to be thicker. While this one, since the soil is younger, that means the thickness is going to be thinner than the old soil. Okay, is that point clear for you? The effect of the time on the thickness of the soil.
Yes.
If it's clear, let's move on to that picture. This picture here summarizes everything that we have go through. So here we can see the soil processes. We have translocation, we have transformations, we have additions, we have losses. Losses could be from top or it could be from down. And also we talk about why the soil is very important for us. We mentioned the agriculture, we mentioned the ranching, We mentioned the home gardening. Okay. Here also we talk about the soil forming factors, talk about the parent material, we talk about topography, we talk about the climate, organisms, and the time. And now we know that formation of the soil is a long and complex process. Now, remember, we talk about the inputs, we talk about the processes. Now we need to talk about the output. So the output is a soil profile. When we say soil profiles, that means the soil is going to be formed in a number of layers. If you see in this picture, you will not find only one layer of the soil. You can see a different kind of layers, and they have physical and chemical and biological characteristics different from each other. Okay, so when we talk about the soil profile, we are going to talk about the different layers that forming the soil. Each one, it has its own color, it has its own textures, it has its own physical and chemical and biological characteristics. So most soil form distinct layers as they develop. When the soil is trying to develop, they form different types of layers. Vertical differences are called horizons. So here we have the vertical differences. Each layers will call it horizon. So horizon, that means zone or layer of soil. So for example, this one is going to be horizon O, this one horizon A, this one horizon E, this one horizon B, and so on and so forth. Each horizon, like I just say, has different physical, chemical, biological characteristics. All of the soil horizons in particular location, from the surface down to the bedrock, comprise the soil profile. When I combine all the layers or all the horizons, then I will have the soil profile. Any question about what does it mean? What soil profile really mean?
دكتور horizon يعني طبقة.
Horizon mean layers. This one is layer.
تمام.
This one is another layer. It means layer or zone. Okay. Any other questions about the soil profile? Okay, let's move on. So the soil profile consists of up to 6 horizons. That means I can have up to 6 horizons. It doesn't mean I have to have 6 horizons, but it could be up to 6 horizons, 6 layers. That means I have the distinct layer of varying color and textures. Usually they are going to be parallel to the surface, to the land surface. So if this one is a land surface, this one is going to be parallel to the land surface. This one also is going to be parallel to the land surface, and so on and so forth. So, and they are visible in the vertical section. If you have a vertical section or if you cut a vertical section, then all the layers is going to be visible. Okay, so let's start with the names for the horizons. So we are going to give names for the horizons designation. So we will have the letter O. Okay, do you have some question?
Yes, I have questions about شو اسمه output files consist of up to 6.
Yes. We said that the soil profile consists of up to 6 horizons. We say that it doesn't mean that it has to be 6 horizons, but it could be up to 6 horizons. It depends on the soil type.
Okay, it's clear.
Okay.
Thank you.
You're welcome.
Okay.
So now we are going to designate a letter for each horizon. So the topmost layer will give it the letter O. The one beneath the topmost layer will give it a letter A, and letter E, letter B, and letter C. Letter O and letter A represent the top soil, while the letter E represents the transition soil, and the letter B represents the subsoil, and the letter E represents the weather bedrock. And the last one, of course, is a solid bedrock. Okay, here again we have the topsoil, we have the transition, we have the subsoil, and we have the weather bedrock. So Now we are going to talk about each and every horizon. So the first one is the O horizon. The O horizon is loose and partly decay organic matter. So the O horizon is the soil's topmost layer. Layer number 1 is the O horizon, and it usually is very thin and consists of loose leaves that is falling from the trees and organic debris from animals. So O horizon is a very thin and consists of loose leaves and organic debris, yani organic remaining. Okay, and beneath that O horizon we have the A horizon. A horizon, it's about 1 to 2 meters thickness, and it's very dark. Actually, it's the darkest layer because it contains the highest concentration of the humus. So in that layer, mainly we're going to have humus. Remember what does mean by humus? Anyone can recall what does mean by humus?
Organic origin.
The remaining of plants and animals.
Yes, the remaining of plant and animals that are going to decompose, right? So this one is very dark because of the humus. Okay, so we have O horizon, which consists of loose leaves and organic debris, and we have the A horizon. It consists mainly it consists of humus and mineral matters, and this one between 1 meter to 2 meter thickness, and usually this one is the darkest layer, mainly because it has highest concentration of humus. Now let's move to the next one, which is the E horizon, or sometimes we call this one zone of leaching. So when the water come to the surface, then it will try to go here. Then the water will try to carry the soluble minerals. The soluble minerals, it will be carried out from that layer to that layer. But the insoluble minerals would not going to be carried out, only soluble minerals. That is why we call this process leaching, because all of these soluble minerals is going to be carried out to the next layers. We call this one layer of accumulation. Okay, and so mainly here I have clay and I have insoluble minerals, because the water cannot carry insoluble minerals, it only carry soluble minerals. And we call this one zone of leaching. So I have O horizon, and I have A horizon, and I have E horizon. Again, O horizon is very thin and consists of loose leaves and organic debris. And the A horizon, it consists of humus, and this one is the darkest layer. It's about 1 to 2 meters. And now we have the E horizon. E horizon mainly consists of clay and insoluble minerals. Why? Because the soluble minerals will going to go through the process of leaching. Okay. Any questions so far about O horizon, A horizon, and E horizon? Is it clear for all of you? Then let's move on to the next layer. We call this one B horizon, or zone of accumulation. We call it a zone of accumulation because the materials is going to be leached from the E horizon to the B horizon, which means that the B horizon is going to gather all the soluble minerals. Okay, so where material.
What's the meaning? I have a question, Doctor. What's the meaning by accumulation?
To accumulate something, to gather something.
Okay.
So accumulation is a process of gathering something. Actually, we are gathering the soluble minerals that has been leached from the E horizon, the zone of leaching. All the soluble minerals is going to leach to be to deposit inside the B horizon. Okay, that is why we call it a zone of accumulation. Okay, so clays are usually abundant in the B horizon. So all the minerals is going to deposit in the B horizon from E horizon, and also we are going to have clays. B horizon are brownish or reddish in color, like you can see here, because of the presence of iron hydroxide that has been transported downward from the horizons above. So we have iron here, and through the action of the water is going to be deposits in the B horizon. So this layer is going to be brownish or reddish because of the iron hydroxide. Okay. Now we'll move to the last horizon, which is the C horizon. This one is slightly altered bedrock, which means that this one is similar to the bedrock, but this one has gone through a process of weathering. Actually, it's going to be mainly chemical weathering. So this layer here is slightly altered bedrock. It has broken and decay mixed with clay produced by chemical weathering. And the last one is going to be, of course, the bedrock. So from the bedrock, we have the C horizon, which is altered bedrock. Here I have B horizon. This one is a zone of accumulation. And I have the E horizon, which is the zone of leaching. And I have the A horizon. Mainly, I will go to find the humus. And here I have the O horizon, which mainly consists of loose leaves and organic debris. Okay. So now we finish the description for the soil profile. Like you can see, I have 1, 2, 3, 4, 5, and 6 layers for the soil profile. Like I said before, it doesn't mean that all the soil profile is going to be consist of 6 layers, but this one is the maximum number of layers. Okay. So again, if you have soil profile, you need to take slice from the soil. If you take a slice from the soil, you can clearly see the layers of the soil. Again, I have O horizon, I have A horizon, I have E horizon, and I have B horizon, and I have C horizon. I have the O, A, E, B, and C. We say that A and B represent the topsoil, and O, A, E, and B represent the true soil. Okay, because the C is partially altered parent material, and this one is the bedrock. So it means that O, A, E, and B represent the solium or the true soil, while B horizon, which is the zone of accumulation, represent the subsoil. Here also we have another picture for soil profile, consists of the layers of the soil. So now we need to classify the soil. Like I say that we have up to 6 layers, but depends on many factors that we have mentioned before. Depends on the climate, depends on the topography, depends on the parent rock, depends on the time, depends on organisms. We have different type of soils. So we need to have a system where we can classify the soil. We are not going to let anyone to classify whatever he wants. We need to have a system. We need to have a standard. So soil scientists worldwide have struggled greatly to develop a rational scheme for classifying soil. So the scientists are trying to come up with soil classification. Not all schemes utilize the same criteria, unfortunately. Not all the scientists all over the world using the same criteria. And even today, there is not worldwide agreement on which one is going to work best for us. So engineers or geologists trying to come up with soil classification, but they didn't agree upon which one is going to work best for them. Okay, so even today, we don't have a system that most of the scientists are using. But we will talking about the in the United States, a country that include many climates. We know that the United States of America is like a just like a continent by itself. So it means that it includes many climates at mid latitudes. Many soil scientists use the U.S. Comprehensive System Classification System, which distinguish among 12 orders of the soil. And according to the U.S. Comprehensive Soil Classification System, they have about 12 types of soil. Of course, the classification based on physical characteristics and environmental of the soil formation. Here we have the 12 orders of the soil classification. We have alpha soil, we have endosoil, we have arid soil, we have int soil, we have gel soil, we have histosoil, we have sept soil, we have the molly soil, we have exosoil, we have spalda soil, we have utili soil, we have vertisoil. So it depends on the climate, it depends on the environment where the soil was being formed. We have like about 12 orders or 12 types of soils. Okay, so I don't want you to memorize the 12 system, but I want you to know or understand the effect of increasing the soil. Here we are going to talk mainly about two types of soil. We have the desert soil, we have the temperate soil, and we have tropical soil. So if you are talking about the desert soil, that means the amount of rainfall is going to be high or low or medium or rare.
And desert soil is minimum, is very less.
Be rare.
It's very small. The amount is very small.
Yes,
Or you can say the rainfall is rare.
Yes.
If you have temperate soil, that means the amount of rainfall is medium. If you have tropical soil,
medium.
If you have tropical soil, that means the amount of water is going to be very
high.
Very high. So, if we are talking about the desert soil, do you think that we are going to find all types of layers? The 6 layers?
No.
No.
Why? Do you think that we will be having O horizon? Remember, the O horizon is the topmost layers. This one, it consists of loose leaves and organic debris. Do you think in the desert soil, this one, do you think we are going to have O horizon?
No, لأنه ما في chemical.
Why do you think we are not going to have loose leaves and organic debris in the desert soil?
Because
there is
there's
no
no
organic
leaching.
life. There is
Low rate
no
of
organic
leach.
life in the desert. There is no leaves or animals living there.
Yes, yes, very good. We said that it consists of loose leaves, and we get loose leaves from trees. And you know, in desert, we don't find a lot of trees, right? And also we don't find a lot of animals. So we are not going to have loose leaves or organic debris. That is why we don't have O horizon layer. Okay? So is that point clear for all of you?
Yes.
And next,
Yes.
And what about, do you see the E horizon? Remember, the E horizon is the leaching, is the zone of leaching. Do you think we are going to have E horizon? Do you see E horizon here?
No.
Why do you
No.
think that we don't have E horizon?
There is no leaching.
There is no leaching. Why we don't have leaching?
We don't have enough water.
We don't have enough water because the water is responsible for the leaching process. The water will try to carry the insoluble, the soluble minerals from zone E to zone B. Since we don't have a lot of rain, that means we are not going to have E horizon. Okay? Is that point clear for you? But of course, we have A horizon, we have B horizon, and we have C horizon. Of course, C horizon is going to be exist in all layers as well as B horizon. Okay? So, is it understandable for you that we don't have O horizon or E horizon?
Yes.
So now let's move to the temperate soil. In the temperate soil, we are going to find all the layers of soil. Okay, we have O horizon, mainly when the weather is temperate. That means I have a reasonable amount of trees. That means I have leaves, I have organic debris. If I have amount of loose leaves and organic debris, that means I will have humus, right? Because the humus is consist of dying leaves and dying organic, right? So if I have O, it means that I'm going to have A. Okay, you see here the thickness of A here is very high compared with A from the desert soil, and the color is very dark, not like this one, mainly because I have real humus. And then I have the E layer, but this one is small because the amount of water is medium. But although I have amount of water, that means a leaching process will take place. So the soluble minerals will go from that layer to that layer, mainly because I have a reasonable amount of water. And then the B layer, which is a layer of accumulation, all the soluble minerals will go into the deposit here along with the clay to form the zone of accumulation. And of course, we are going to have the layer C, where we have the chemical weathering here. And of course, this one is a bedrock. Now, we'll move to the tropical soil. In the tropical soil, like you can see, do we have O horizon in the tropical soil? Do we have O horizon in tropical soil?
No, doctor, we don't. We
don't have.
Why we don't have? Why we don't have O horizon in tropical soil?
It will turn to a soil fast.
Because water is always available. We don't have decaying plants.
Okay, I'm not
Because
going
we
to
don't have a
answer
lot
the
of
question. We don't have O horizon here, and also we don't have E horizon. Okay, I think I'm going to lose this to a homework. Okay, we are going to turn this to a homework. Every one of you, I want you to put the 3 type of soil: desert soil, temperate soil, and tropical soil. And if there are any missing layers, I need you to give me explanation for that. Okay. The time of the lecture is over right now. I hope you enjoy the lecture here. Did you understand the homework?
Yes,
We
So
should
try
talk
to-
about
but
each
we need
layer.
ممكن دكتور ترسل هوم ورك بايميل توضح ايش تبغى فيه بالضبط.
Okay, I'm going to send it officially for all of you. Okay.
Okay.
Again, don't copy from each other. Otherwise, you will get 0. Okay. Try to solve it by yourself. Okay, I'm going to finish the lecture. See you next time. I'm going to check with attendance. I think all of you, those who I give them attendance in the beginning of the lectures, they can leave right now. Okay. Okay. Thank you for attending. See you next time.
عمار حاضر. السلام عليكم.